and I hope you have somewhere on your study sheet a little reminder of when it's tessellation, when I'm trying to tile a floor, how do I approach it? If it's only one shape that you're using, only one shape, just find that interior angle of that one shape. It's going to be regular polygons, by the way. And see how many times it fits into 360. If it's a whole number, you're good to go. You can use that for tiling purposes. If you're using several shapes, like on page 49C, we use different shapes. Then you have to find the interior angle of all of them. You have to use each one of them at least once. And then whatever is left over, you're going to try to fill it with whatever you have available, right? To make sure that gap is closed. You have a whole full 360-degree fill, so to speak, right? And so what happens, though, if a question says, hey, we're using triangles and squares, what is possibly a third shape that we could use to make this work? How do we do that, okay? So we're going to do that on page 50. Okay, so Natisha's planning on using regular octagons to tile a floor. Can he tile a floor using only octagons? If not, what other shape can be introduced to tile the floor? And I'm telling you, you already know everything you need to make this work. But let's figure out the interior angle of an octagon is 8 minus 2. Octagon, I hope you know that that's 8. N is equal to 8, right? Just by the name. You multiply that by 180, you divide it by 8. What's that interior angle? 135? Some of you have that table on your study sheets. Pretty impressive how you made that work. You might have to say no to that down the road, though, once we get to the end of the course. So we know that, so we'll do a check. 360 degrees divided by 135. If you do that, you'll get 2.66, and that keeps going. So can't use only octagons. Okay? You cannot have an exact number of octagons to make that work. Okay? So what we're going to do is we're going to do this. 360. Let's see how many octagons we can use to get this number down. So we're going to use one octagon. We're going to use another octagon. Let's see where we're at that point, right? So 360 minus 135 minus 135. We're down to 90. I made this one nice and easy. Right? So you're left with 90 degrees. So you've got an octagon, you've got an octagon. What shape will make this one work? What do I need to introduce? A square, right? But I will continue. I will assume we don't know what shape goes in there. Okay? We need a polygon with an interior angle of 90 degrees. Okay? So a square should be introduced. And I'm going to make this complicated, this question, okay? Why, Mr. Erickson? Why would you have to do that? Just trust me. If the interior angle is 90, what's the exterior angle of this polygon? What do the interior and the exterior always add up to? 180, right? So if the interior is 90 Then the exterior is 180 minus 90. So that's 90 degrees. Duh, right? Yes, I know. I'm making it too complicated. We're technically done already, remember. But what if it's not a 90? What if you get something that isn't 90, right? So then I will use this exterior angle and use the formula, which is 360 over n. That is the formula for exterior angle. Put a 1 underneath. We cross multiply and divide. (360) divided by 90, 4 sides. Okay? Therefore, use a square. You don't have to say use a square. You could say use a four-sided polygon. But I think a square would be quite all right to use here. And I will highlight those so you can follow my trail here. We found this 90 here, right? And so that's the 90 that I'm talking about. That's the interior angle that we need. Instead of using the formula for interior angle and solving for n, I quickly find my exterior angle. Like I subtract that interior from 180 to get my exterior, and then I solve for the number of sides. You want to try that real quick with 50, the question below this while I do my attendance? It's the same kind of idea. Try the question right below this. Same style, not exactly the same, but read it. See if you can figure it out, okay? All right, so we're using 3 different shapes. They tell us that. They all have the same length, so we're talking regular polygons, right? At each corner, there's 1 square and 1 hexagon. What is the third shape? All right, so we know that for a square, it's 90. For a hexagon, it's 120. You can either calculate that or you just have it on your study sheet. You can use the interior angle formula. So what's the third shape that I need? Okay. Sorry, what did I do there? Yeah, that last one is a question mark. So the way I approach this is I go 360 minus 90 minus 120. And you get 150 degrees. Now, you might be tempted to say, well, what if I take another 90 away, right? What if I take another 90? What are you left with at that point? You'd be left with 60, right? So you can go that route, or you can just stop here and see if you can find a shape that has a 150 degree angle. Okay, so I'll say here, need third shape with interior angle of 150. Okay, so that means that therefore exterior angle would be 180 minus the 150, so that'd be 30 degrees, right? The exterior angle therefore of the shape I'm trying to find has to have an exterior angle of 30. So I just go 30 is equal to 360 over n divided by 1, multiply and divide. Okay, so that'd be 360 times 1 divided by 30, and you get 12. Okay, do we have a name for that one? Dodecagon. So if you actually you can say dodecagon or a 12-sided, I'll be fine either way. Okay, the third shape, the third tile needs to have 12 sides. So this is one route you could have taken and you would have been fine. Okay, So this is option one, option one. Okay. Option two is you go minus 90. If you take away 90, you're left with 60 degrees. So you've used a square, you've used a hexagon, you're using another square, you're down to 60. What is that? What shape would make that one work? A triangle, right? Equilateral triangle. So if you go this route, this is option two, it will work out regardless of how you approach this. That's what I'm trying to say here. Option two is interior angle of 60. That means that the exterior angle is 120. So we go 120 is equal to 360 over n. If you divide by 1 here, you go 360 divided. So it's 360 divided by 120. N is equal to 3 sides, right? A triangle would also work. Okay, so it's kind of like choose your own adventure kind of thing. Sometimes there's multiple, sometimes it's very obvious that there are no other ways of doing it. All right? You seem so excited. I hear you guys, I hear you. Okay.